Welcome you students. Again I come up with a question based on the Varignon's theorem. A horizontal rod AB of length 12 meter is acted upon by a set of forces as shown in figure. Determine the magnitude, direction and position of the resultant. Okay. So this is the exact picture given for us. So here number of forces are acting, namely 1 kilonewton, 1.5 kilonewton, then 1 kilonewton, again 0.5 kilonewton. Okay. So this is the setup and arrangement of force. So for this we need to find the magnitude, direction and position of resultant. Magnitude, resultant how much, and direction and the position. Since here the beam or slab is horizontal manner, we need to specify the horizontal distance in order to position the resultant force. So here, as far as this diagram concerns, we need x distance to specify it. So solution. First, just try to identify the number of components, that means horizontal forces and vertical forces. Since here the inclined force is there, just by seeing it we cannot predict the resultant value, okay, magnitude of resultants. So here what we are going to do is, first we are going to draw the free body diagram in order to or divide the components. So for that I am going to take the beam. So with the same measurement A, B, C and the end with D. Okay. And here the first at A there is a force which is a vertical force, and downwards which is with 1 kilonewton. It's a 1 kilonewton. It's a vertical force. Let it be. And then at the point B there is 1.5 kilonewton which is an inclined force. So when you are coming across the inclined force in the resolution of force method, we understood there would be a possibility for the horizontal force and the possibility for the vertical force. Depending upon the direction, we will be giving the direction for each components. So here the force is just acting downwards, something like this. Am I right? This is how. So here I can say the force is horizontally towards left and vertically down. This is the possible one. So in well designating this force, I can say 1.5 for horizontal force cos theta. Here it is 60 degree. And for the vertical force 1.5, it's a vertical, so sine 60 degree. Vertical component, it's a sine. Come to the next force. Next also it's an inclined force. So here the force direction is going something like this, in this direction, right? So I can say horizontally it is towards left and vertically downwards. So horizontally towards left and vertically downwards. This is how. So here designating this force, 1 cos horizontal component cos its horizontal inclination, so 45 degree. So here 1 sine 45 degree. It's a vertical component. And what about the next force? It also inclined and its direction is going something like this. In the similar manner the force which is acting on the C point. So here comes, it is going downwards, right? Downwards I can say horizontally left and vertically downwards. So horizontally left, the force acting on the D is horizontally left and vertically down. So here I can specify 0.5 kilonewton cos for horizontal force and its inclination is 30 degree. And here 0.5 sine 30 degree. It's for vertical components. That's all. So measurement we know, each component A to B, B to C and C to D with equal measurement for mm. Okay, fine. So next step, in order to find the resultant force, first we need to resolve sum of horizontal force. Resolving sum of horizontal forces. Sum of horizontal forces. So when you resolve it, sum of horizontal force, summation of H is equal to, add all the horizontal forces. So here comes 1.5 cos 60 degree, and here it is directed to the right side. So sign concern when you are resolving horizontally, right in the sense it's a positive sign, horizontally left in the sense it's a negative sign. When you come to the vertical components, vertically upward is a positive, vertically downward is a negative. So here it is moving towards right side horizontally. So it's a positive 1.5 cos 60 degree. 1.5 cos 60 degree. And the next horizontal force which is moving toward left, horizontally left. So sign concern it's a minus 1 cos 45 degree. 1 cos 45 degree. And next horizontal force is 0.5 cos 30 degree, which is moving towards left. So it as well carries minus 0.5 cos 30 here, cos 30 degree. Okay. So if you do the calculation, okay, by using the calculator, you will get 0.09 kilonewton in terms of minus. So summation of H can be taken as 0.09 kilonewton magnitude. The minus sign represent the horizontal force is acting towards left. So here I am going to represent it moving in left side. So next, resolving after completing sum of horizontal force, resolve sum of vertical forces. So when you resolve it, sum of vertical force is equal to, add all the vertical force 1 kilonewton acting downwards. It has the minus sign, minus 1. And the next force 1.5 sine 60 degree acting downwards, it carries minus. So 1.5 sine 60 degree. And here 1.1 sine 40 degree, which is acting downwards. So it carries minus 1 sine 45 degree. And the next force 0.5 sine 30 degree, which is acting downwards. So it as well carries the minus sign. So minus 0.5 sine 30 degree. Okay. So just calculate it. Just feed it in your calculator just like this and find out the value. You will get in terms of kilonewton, and I can say the magnitude will be minus 3.256. So the vertical force, sum of vertical force can be written as 3.256 kilonewton magnitude, and this negative sign says this vertical force which is acting in the negative direction, that means downwards. So here by removing the negative we can note as downward force. Sum of vertical force is downward and sum of horizontal force is towards left, negative direction. Okay. What is the next step? Sum of vertical force and sum of horizontal force is known, right? Now we can just identify the magnitude of resultant. So R can be identified by the formula root of sum of horizontal force square plus sum of vertical force the whole square. So here substitute the values. Sum of horizontal force is 0.09 whole square plus here 3.256 the whole square. Okay. So here just simplify it. You will get the R resultant value in terms of kilonewton, I can say roughly we'll get 3.279 kilonewton. Okay, this is the answer for resultant. Always magnitude of resultant will be a positive one. Never you will get any negative sign. Okay. So next stage, the resultant, magnitude of resultant got over, direction we need to find. So here apply moment, take moment, can predict where it is moving, clockwise or anti-clockwise. So when you take the moment, here I am going to take sum of moments which is acting on the beam about the point A. Okay, I am going to take about the point A. Any point we can consider, but I am going to take the moment about the point A. So if you take the moment about A, see here we need the measurement, so I am just noting this 4. This is with 4 mm, okay, 4 mm, and here as well the distance is with 4 mm. Okay, sorry, 4 meter. Okay, let it be. So you are going to take the moment about A. Always remember the force acting on the point, consider the point will be 0. Moment will be 0. Why? Because we know the formula for the moment. Moment is equal to force into its perpendicular distance. So when you are considering a point, if you take the perpendicular distance for this force 1 kilonewton, there is no perpendicular distance, so it will be 0. So here concern, I can say 1 into 0 will be 0. Directly you can write 0 as well. So here the next force, look at this, next force 1.5 cos 60 degree. Okay, if I say as per the principle of transmissibility, it is said that means force acting on any point along the line of action which will give the same effect. Okay, so here comes for this, the line of action of the force is here at the A. It is from the B point, but the line of action is coinciding. Am I right? Coinciding. So I can also say it is acting from the point A. It will produce the same effect. So consider it is acting from the point A. So if you take moment for 1.5 cos 60 degree, 1.5 cos 60 degree into its perpendicular distance. What about the perpendicular distance? Whether this force has the perpendicular distance? There is no perpendicular distance. So it is what? 0. Directly you can write 0. You can write 0. Okay. So here as well there is no perpendicular distance, so it is 0. And then 1.5 sine 60 degree. So here is the force. Here is the line of action. Okay. So force into its perpendicular distance, 1 sine 60 into its perpendicular distance. If you take 90 degree distance, this is the 90 degree distance. 4. So 1.5 sine 60 into 4. Okay. What about this sine? What about this sine? Actually, this force is acting downwards. Here is the A point which is considered for moment. So this is how the force is acting downwards. Am I right? How this body moves because of this force? It is moving in clockwise. So for assigning the sign, it is positive. Okay, not negative, it's a positive. And move to the next force which is acting 1 cos 45 degree. Already here I explained this force as well. The line of action is coinciding the point A. Okay. If I say the line of action for the force, these three is just coinciding. I can also replace which is taken from A as per the principle of transmissibility. So similar way for 1.5 cos 60 degree we put 0, right? Similarly it has no perpendicular distance, so I can make it as 0. I can make it as 0. Okay. Then the next force which is downward, it is similar like 1.5 sine 60 degree which is acting downwards. So its sign is plus. It's downwards, so it's rotate in clockwise direction. The force will act in clockwise direction. So 1 sine 45, 1 sine 45, and its perpendicular distance. Look at this, it's perpendicular distance about A. So this perpendicular distance will be 4 plus 4, we get 8. 4 plus 4, we get 8. Okay. And then next force, I said the horizontal force acting these three is having the same the line of action. So I can consider it is acting from A. So there is no perpendicular distance. So for this as well 0. And the next, look at this, 0.5 sine 30 degree, and this force into the perpendicular distance of it about A. This is the perpendicular distance A to D. So 4 plus 4 plus 4. So you will get 12. So 0.5 sine 30 degree into 12. Okay. So if you calculate it, sum of moment about A point, we get just 13.853 kilonewton. Okay, 13.853 kilonewton. So now we got the direction. Here the answer is positive. So that we can say the moment acting is clockwise, which is a clockwise. Okay. And see, now we found the resultant moment. Okay. And the next thing is we need the direction. The direction needs to be found. Okay. Then only we can properly locate the resultant force. So we need in which inclination this resultant gonna have on this beam. So in order to find the resultant, alpha is equal to, it's a direction. Alpha is equal to tan inverse of summation of V divided by summation of H. So already we got the value for summation of H and summation of V. Just substitute it. Tan inverse of summation of V, we have the value 3.256 divided by 0.09. So that you will get the alpha. So here I can say you will get the alpha 83.17 degree. So alpha. Okay. Now if you plot it, since you are having summation of H and summation of V, I can say you can plot the resultant force in general manner in order to specify the resultant with respect to this angle, given got angle, we can specify it. So here summation of H and summation of V, which is summation of H is negative direction in the sense somewhere here summation of V going to happen, summation of H, horizontal force, right? Sum of horizontal force is negative direction, so here it's gonna happen. Sum of vertical force, which is which is negative, which is going downwards. So downwards in the sense in the XY axis, summation of V will be somewhere here. So resultant will be between summation of H and summation of V as per the resolution method. Okay, in between summation of H and summation of V. And our angle is 83.17, right? So here between this I going to note the resultant or, and with the angle alpha 83.17, this is alpha. Now we got the direction, magnitude of resultant or, okay, All the things we got. Only one thing is remaining, the position, x direction, x distance, how much it is, where it is actually located with respect to A, where it actually located. We got the inclination and magnitude, but where we don't know. So in order to specify it, already I taught you in the introduction part of Varignon's theorem, whenever you are going to locate the resultant force, we undergo the theorem called Varignon's theorem, right? So the same Varignon's theorem I going to apply here. Okay, with I don't have enough space, so I just going to rub this portion. Okay, rub this portion. Let me rub it. So now I going to apply the Varignon's theorem. Varignon's theorem. Sum of moment about any points. Here already I have taken moment about A. So moment about A is equal to resultant moment. So r into its perpendicular distance. I have taken it as small r. Okay. Then what happens? Sum of moment about A, I got the value which is 13.853, which is equal to, or resultant we already got in this step 3.279 kilonewton, okay, into r, so that I will get the distance, if you do the cross multiplication, okay, what we get is 4.22 meter. Just do the calculation, you will get 4.22 meter. Actually this r is a perpendicular distance, not the x distance. Since the beam is horizontal, if you want to locate it properly, we need a horizontal distance. Okay, so what we're going to do is we're going to form this horizontal distance x. So just think, here's resultant force we have plotted. We know for the resultant force, this is the summation of h is one of the horizontal component, and sum of vertical force, it's a vertical component. Okay, so in order to specify the x, I going to apply Varignon's theorem by including summation of vertical force, sum of vertical force. I going to take the what moment. That means sum of moment about A, which is equal to, if I applied for sum of vertical force into its perpendicular distance, okay, you will get as x. Okay, if you are applying for horizontal force, sum of moment about A, which is equal to sum of horizontal force into y. Its vertical distance is x. For this horizontal force, the vertical distance is y. Okay, in the logical manner, I am going to take for the first one, so that I will get the x value. So here all the times answer is known one. So x is equal to sum of moment about A divided by sum of vertical force. So that what would be sum of moment about the A, which is already been found 13.853, divided by sum of vertical force, we got the answer 3.256, right? So just simplify it, you will get the answer 4.25 meter. 4.25 meter. So its distance is 4.25 meter. So at last we must show the result. Okay, in order to show the result, I just going to wipe it off. Actually in our question the beam is something like this, with the point A, B, C and D. Each of the segment A to B, B to C is with 4 meter and 4 meter. Okay, so here it is 4.25 meter, right? So when we are locating it 4.25, in the sense this distance is 4, we have taken the moment from A, so the measurement shows from A, okay. So somewhere between B and C segment nearby B, I am going to have the point for the resultant. So this is the distance with 4.25 meter. So in the points, you can note the resultant force, and we know the resultant force is just going something like this, especially in the third quadrant. So the inclination for the resultant must be taken something like this. This is the R, and its inclination alpha is mentioned there, okay, and then the resultant force magnitude also we can write over this, which is 3.279 kilonewton. Inclination of alpha, here you can mention it, so 83.17, okay. And if you want to represent the perpendicular distance, if I show the line of action, you can take the 90-degree distance. That distance is nothing but R, which we have measured as 4.22, okay, right. So I hope you understood when you are having such kind of force system, how to identify the magnitude of resultant force and how to locate it, how to find the direction of it, okay. Thank you so much.